Okay, good morning. We're going to continue with notes number 127. We did example 1. We're going to look at example 2, where we also have 3 theta, but this time it occurs in 2 places. That's okay because all of our angles are in terms of 3 theta. So we can use this method. So here's my given problem. And so the method is going to be just solve it like normal, and then we'll deal with the 3 theta. So the best idea is to switch to x and y. And in this case, I have y equals the sine of 3 theta. So I'm going to do that. So this would be cosecant, that's 1 over y, and sine, that's y, so that's 5y. Okay, let's just go ahead and solve this like we normally do. Cross multiply. 5y squared equals 1. Divide by 5. Y squared equals 1/5. Take the square root of both sides. Y equals plus or minus the square root of 1/5. Now, that's not a common angle. Look at our table here. There's no square roots of 5 in there. The square roots of 3, but not 5. So we're going to have to get a decimal for this. So let's go ahead and do that. Y is approximately equal to square root of 1/5. And that's 0.447. Let me just keep 3 significant digits. Good practice. Plus or minus 0.447. My final answer is going to be 2 significant digits. But I have to remember now that that's going to help me find 3 theta. But let's go ahead and find out where the y coordinate on the unit circle is about that. So on my unit circle, here's y. Remember, this is at 0, 1. So half is there, and then a little bit below that is my solution. I have 2 points on the unit circle. If I go down here the same distance, I get 2 more points on the unit circle. So there's 4 points on the unit circle that have a y coordinate of plus or minus 0.447. We have to figure out what the angles are. Remember, the angle's the measurement along the arc there. It's not going to be that much different than that, but it will be different. So now, without changing that, I'm just going to take the inverse sine of that. So second sine of my answer, and I get 0.46. And I'm going to just use 2 decimal places from here on out because I'm good. I got my angle. 0.46. That would make this negative 0.46. And if I want to find these other solutions, this one would be 0.46 pi minus 0.46. So I'll do pi minus my answer, 2.68. I don't need this one, but if I did do that one, it would be pi plus 0.46. That's 3.60. Okay. Now, here's where we're going with this, is that now I'm really solving for my angle here. So these are the angles. I took the inverse sine. So what I did is I took the inverse sine of both sides on this equation. So I had 0.45, let's say, equals the sine of 3 theta. I took the inverse sine of 0.45, and that should give me 3 theta. So that was my 0.46 equals 3 theta. So these are actually values for 3 theta. So if I'm using, if there's a multiplier next to theta, I have to remember that my solutions are 3 theta equals 0.46 plus multiples of the circle. Usually it's 2k pi, but in this case I could represent both of these solutions because they're just a half a circle away, so every multiple of pi. So it's plus k pi. And my other one is going to be 3 theta equals approximately, I'll use this one, the next one up, it's important, 2.68 plus k pi. So those are representing my general solutions, but they're not theta, they're 3 theta. The next thing, now the second one I wrote is going to cover those two solutions, so that really represents all of my solutions. The next thing I'm going to do is solve for theta, so I have to divide by 3. And I divide this by 3, but I'm just going to distribute that division there. Same thing over here. Just divide everything by 3. So now I got theta equals approximately, and this is 0.15 about, rounding, plus k pi over 3. And the other one is theta is approximately 0.89. That's 2.868 divided by 3 plus k pi over 3. This represents the general solutions to my equation. Okay, so any of those solutions would solve this equation. Now I'm going to find out what solutions there are on the unit circle that satisfy this. And this unit circle is for 3 theta, but really this is going to generate more solutions on the unit circle. So my solutions on the unit circle, which I represent as the interval from 0 to 2 pi, not include 2 pi because 2 pi is the same as 0, are going to be generated from those two equations. So what do is I have it down here. I'm just going to take my one solution, 0.15, and add multiples of pi over 3. So the first multiple was k is 0, is just 0, so that's 0.15. And then I take that, add pi over 3, I get 1.20. Add another pi over 3, and I get my next solution, and continue to do that until I am I'm outside of my range. And that's bigger than 3.14, so that's outside of my range. And over here I do the same thing with the 0.89. So this gives me 1, 2, 3, 4, 5, 6 solutions that I can put on my solutions between 0 and 2 pi. So I'm going to try to put them in order of 0.15. The next one is 0.89. The next one is 1.20. The next one 1.94. The next one 2.24, and then 2.99. So if I want the solutions on 2 pi, I have these, 0 to 2 pi. Okay, so there it is. I know that having a multiple next to the theta will lead you to always having to solve for theta in your general solutions. Okay, well, I hope this helps. Let me know if you have any questions. Have a great day.